How can a massive boat float, but a much lighter stone sinks directly? Let's find it out by going back 2,000 years ago in Syracuse, Italy. The legend says that Archimedes, a Greek man, had a genius idea while taking his bath. He had the intuition that the force he could feel pushing him upwards was somehow related to the water his body displaced in the bath. After many experiences, he finally stated in his book, called On Floating Bodies, written in 234 BC, what we today know as the Archimedes Principle. Any object, totally or partially immersed in a fluid or a liquid, is buoyed up by a force equal to the weight of the fluid displaced by the object. With this striking sentence, he had just entered the history, setting up the foundations of the static of fluids. Now, let's see how does this apply to our boat and our stone. Considering an object immersed in the water, we see that vertically, two forces apply to the object, the weight of the object and the buoyancy. This means that when an object floats, its weight is fully supported by buoyancy, and therefore it doesn't sink. This is exactly what happens with the boat. Both the load of the boat and the volume of water displaced by the boat are important. Adding more load could break the equilibrium and sink the boat. Zooming at the stone now, the volume of water displaced by the stone is exactly equal to the volume of the stone. The stone's density being greater than the water's density, the weight of the stone is greater than the weight of the water displaced, and the stone sinks.
Please do not subscribe if you prefer to enjoy this sweet bliss of ignorance.